Thank you for attending the International Construction Week at FTK 2021. Our slot 7 will begin shortly. Please kindly ensure that microphone is in mute mode and the camera is in open mode during this session. Your cooperation is deeply appreciated. Thank you. Assalamualaikum and a very good morning, ladies and gentlemen. A very warm welcome on behalf of the Organizing Committee International Construction Week at FTK 2021 to our distinguished guest speakers this morning, Mr. Shaikh Abdullah bin Shaikh Othman, Principal Engineer, Pipeline Engineering Onshore of Petronas, Ms. Swee Ling, Staff Engineer, Pipeline Integrity of Petronas, Ms. Salwanie binti Zakaria, Staff Engineer, Pipeline Integrity of Petronas, and Ms. Aisyah Ahmad, Staff Engineer, Pipeline Integrity of Petronas. On this virtual platform, welcome to the International Construction Week at FTK 2021 Slot 7 with the title Excavation Works for Onshore Pipeline Installation. Without further ado, it is now my pleasure to invite Technologist Dr. Nik Munira binti Mat Hassan, our moderator for today, to lead our webinar, Excavation Work for Onshore Pipeline Installation. The floor is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh and very good morning. Thank you very much for Ms. Farisha as our MC today. All the participants can hear my voice clearly?
Yes.
Okay, thank you very much for the feedback. Okay, ladies and gentlemen, welcome to the International Construction Week FTK 2021. So I am the moderator today. So let me introduce myself first. Okay, my name is Dr. Nik Munira binti Mat Hassan. I am one of the lecturer in the Faculty of Engineering Technology, University Tun Hussein of Malaysia. So I will as a moderator for today and very so glad to have here our guest speaker, four guest speaker from Petronas. Can we have the sharing session about the title of Excavation Work for Onshore Pipeline Installation. Okay, I want to introduce, first is Mr. Shaikh Abdullah bin Shaikh Othman, our first guest speaker. He is a Principal Engineer, Pipeline Engineering Onshore of Petronas. Shaikh Abdullah. Okay, the second one is Ms. Swee Ling as a Staff Engineer, Pipeline Integrity of Petronas. And third one is Ms. Salwanie bin Zakaria, Staff Engineer, Pipeline Integrity of Petronas. And we also have additional guest speaker, Ms. Aisyah Ahmad from Pipeline Engineer Petronas. So they will be able sharing today about the excavating work for onshore pipeline installations. Just a little housekeeping before we started. If you have any questions during the session, so please type the question in the chat box or in the Facebook comment, so I can take that question at the end of the session. So now, without further ado, let me introduce our guest speaker today. First, we started with Ms. Shaikh Abdullah bin Shaikh Othman. Mr. Shaikh Abdullah bin Shaikh Othman, he is Principal Engineer, started his career as an Executive Civil Engineer under Transmission Gas Petronas Gas Berhad. And then he joined the Oil Gas Petrochemical Technical Services Sdn Berhad, and also a joint venture company with Nova Corporation, a Canadian-based company, to provide an engineering consultant services. He also appointment as a technical professional at Group Technical Solution under Project Delivery and Technology, and then providing solution to Petronas Operation Unit on Offshore Pipeline Design and Pipeline Integrity Management System. So the second speaker, Ms. Swee Ling, is a staff engineer with GTS Petronas and has more than 12 years experience in pipeline engineering. She also provides the technical consultant services on the pipeline constructions, pipeline integrity assessment, and repair activity for Petronas operating unit She also completed several projects, including offshore pipeline design and installations, pipeline service conversion study, and also pipeline optimization study. The third guest speaker, Ms. Nur Salwanie Zakaria, has been serving Petronas for 13 years in providing her expertise in pipeline industry, in onshore and offshore pipeline design operations, and also the pipeline integrity. She also active in develop, review, and enhance Petronas technical standards and provide consultation for technology qualification for pipeline integrity application in Petronas. So the fourth one is our additional guest speaker, Ms. Aisyah Ahmad, has 13 years of experience in oil and gas industry as a pipeline engineer. She has been with Petronas since graduated from University Technology Petronas in Bachelor Science in Engineering Civil. She also has the various experience in pipeline engineering, including involved in Garaf Field Development Project and also Turkmenistan Gas Development Project. So I welcome to our speaker. So that floor is yours.
Assalamualaikum and good morning. Our first speaker will be Miss Ling.
I'll start.
Yeah.
Okay. Thank you, Dr. Monira. So let me share my screen. Okay. Very good morning to everybody. My name is Swee Ling. I'm Pipeline Integrity Engineer from GTS Petronas. So we would like to thank UTHM for this opportunity for us to share our experience with all the participants in this session. So without further ado, our topic for today is about the excavation works for onshore pipeline installations. So let me go through the slide. Okay, this is the overview of the activity we will be facing when pipeline installation during pipeline construction. So I will share more about the pipeline spread, construction survey, the right of way preparation, and the trenching activities. This is the actual picture of one of the projects conducted by the Petronas team long time ago, but we took this as our background. So let's go through the construction spread. Okay. The typical pipeline spread is consists of a few sections. So we started with pipeline survey. So in order to install a pipeline, we need to conduct a detailed survey on the site so that we will avoid encroachment into the private land. So if the land is not belong to us, so the land acquisition process need to be started. So the starting of the activity might take long time at the beginning when all the land matters is settled, then everything will follow as per plan. So briefly go through because later my colleague will go in detail for each of the activity. So after clearing the site, after we get the correct site work boundary, then we start clearing the site and then perform some removal of the surface, ground surface, including the rock and plant. So after this, then it will, okay. After that, pipeline will be string along the pipeline right of way, and then welding for each of the location. Pipeline coating also will be part of our activity at site. And then when the coating and when the coating and the testing has been done, the pipeline will be lowered into the trench that we have been prepared for the pipeline. So after the pipeline is in the trench, before we can operate the pipeline, one more activity that we need to be in mind is to inform the authority on the new project or new pipeline that we have installed. So before we can start operating the new pipeline, we need to submit all these as-built drawing, all these related documents, and invite them for the testing, the hydro testing, to ensure that our pipeline is safe to operate in the future. So when everything is, we get the, after DOSH inspect and witness the testing, so they will give us a permit, which we call it as permit to operate. So with the permit to operate, then we can start operating the pipeline. When everything is done, then we'll start clearing out the site and then reinstate back all the trees or the land back to the original as much as possible. So next, this is some of the spread for countryside. Countryside is normally straightforward because it does not have much buildings that we need to consider, or underground buildings that we might need to reconsider the routing of the pipeline. So normally after clearing out the site and install the pipeline, so the reinstatement activity is much easier compared to the urban area. So this is the example of the pipeline installation in the urban area. So we might consider different construction method to, if there's existing building that we need to avoid or we cannot avoid. So there's the difference for urban. For urban area, there's more cautious need to be in mind, because we need to put the safety of the people first, because it involves more, the population is more at this area. For these areas, most of that construction is at places where there's less people. So there's during pipeline installation or design, we need to consider, we call it class, location class with different design information. So that will affect our design and construction method. Okay, just stop me if any questions. So I will go to our first spread or first activity in our pipeline construction, which is to conduct the construction survey. So I think this equipment is very familiar to the civil team, the civil theodolite, as what we have studied previously in the university. Also, we use this equipment to conduct the leveling. So a construction survey is performed to gather information, detailed data, to enable the design team to complete the design of all section pipeline, including the road. We need to make sure to identify the boundary of the right of way and the work site location. So this activity include the brush cutting of the center line and the cross section offset of sufficient width to provide a clear line of sight for the surveyor. So next is about a typical construction right of way width that we adopt during the pipeline construction for so that the people who perform the construction will have a clear sight for all the activity. So if we can see from the small picture down there, at the left side, there's where we stock all the excavated soil, and then at the right side is where the activity is ongoing to perform the pipeline stringing, to perform all the welding at the right side. Okay, so what is right of way? And right of way is the the width, the space of land allocated from the center line of the pipe, so that the operator first is during the construction, so that we can perform our construction, and then in future when the pipeline is in operation, is for the operator to perform their maintenance and inspection also. So the area of the right of way, all the temporary working space, and all the access route used for the construction are completely clear of tree and brush during this phase. The stumps are removed from the ditch line, spoil storage areas, and all the area to be graded. Logs are salvaged wherever possible. So the bulldozer with special attachment cut or knock down any remaining material. Okay. Okay, this is for some special condition. The pipeline might go through mountainous area, so we need to consult the civil team on the excavation and the slope design requirement, such as the slope height and the width. And if the location is too steep, and then we need to have the proper protection for the slope to avoid the slope failure in the future. Okay, after the cleaning and grading activity, the inspection staff will check the permanent right of way or the temporary work area boundaries are clearly marked by the inspector, and cleaning are confined within these boundaries. The temporary land use agreement are executed prior to the cleaning right of way and comply with each specific provision. For all those utilities, let's say we perform the installation at the urban area, so those exposed utilities will be marked and then protected, and we also need to ensure that those drainage affected during the construction are reinstated and not blocked. The timber, debris, and earth are not placed in the water course, and sufficient area is clear to ensure that the slash and debris is not mixed with the ditch and great soil, and that spoil is not placed on unclear ground. Okay, that's all for my sharing on the construction survey and the right of way preparations. I would like to pass the slide to my colleague, Puan Salwanie, to continue with the sharing.
All right. Thank you, Ms. Ling. So I will proceed on the trenching, pipe stringing, pipe bending, and fill joint coatings. Okay, next, Ling. All right, so we proceed with trenching. Okay, so normally the trenching will be excavated using the wheel digger, supplemented by the backhoe to dig the side bends and area requiring the extra depth. So usually our pipeline is laid along about 100 kilometers, so it will be time consuming if we are using the manual digging or backhoe. So usually that's why we are using the wheel digger to proceed with the trenching activity. And then for the spoil from the ditching activity, usually we will start at the adjacent to the trench, as per previous slide that shown by Ms. Ling earlier, so that it will ease our activity for the backfilling later. So that will be along the topsoil will be put along the excavated area. And then the finished ditching will be to the correct depth and width to suit the pipe diameter. So usually the trench dimension will be varies accordingly based on our pipeline diameter, or according to the nature of the terrain where we will lay our pipeline. Okay, but however, the general rule of thumb, specifically the trench should be wide enough for us to lower down our pipeline so that it will not pose any extra stress or any extra excessive stress that we incur to our pipeline, as well as our ditching should be depth enough so that it can cover to avoid any contact with any pipeline or other any utilities. So in our practices, usually according to our authority, we put or we lay our pipeline usually around 1.5 meter to 2.5 meter buried under the ground. Okay, so next feeling. Okay, so this is, as I mentioned earlier, is trenching equipment. So we are using trenching machine or the wheel ditcher because it is suitable for the long distance and flat terrains as well as high efficiency rates during the construction. So we also use the pipeline padding machine, which is we use the in situ earth, the one that we excavated earlier. So that and then after that we start to remove the debris from the excavated soil, and then later to put as a coating as additional protection to our pipeline to avoid damage to the coating to our pipeline. Okay, so this padding, we call it as a padding as well, is to reduce the premature pipeline corrosion and improve the pipeline longevity throughout our operation life. Okay, next. Okay, so what do inspector monitor during the process throughout our trenching process? So we just to ensure that the correct dimensions, for example, I mentioned earlier about the depth, so that it will avoid contact to other pipeline, to the intrusion of the third party, as well as the spoil place separated from topsoil on the strip ground, and then the sloping during the dishes, as mentioned by Swee earlier from the figure. So the hand trenching near the buried facility so that we did not do the potential damage to our utility or to our pipeline, and then the proper alignment of the trench, gaps of the plug to allow the landowner, livestock and the wildlife crossing. So as well as we need to ensure that the drainage is not blockage during the construction. Okay, next. Okay, we move to after we do the trenching. The trenching is completed. Then the next process is the pipeline stringing. So actually, what is the pipeline stringing? So pipeline stringing is basically the process where we deliver the line pipe and we align the line pipe along the trench that we excavated area. Okay, so upon completion of the trench activity, the line pipe will be delivered to the site. So we use the crane to lift and load the line pipe from the truck, and then we just align side by side our line pipe along the trenches. And then so the pipe are angled slightly to allow the end hooks to be removed and prevent damage to the bevel. So because the bevel later we will use to welding between the line pipe along the trenches that we excavated. Okay, next Willing. Okay, so usually during the stringing process, there is a site supervisor that need to monitor at site. So we need to ensure that the pipeline is being handled properly so that it will not cause damage to our pipeline. That later it will we can welding the line pipe one to another perfectly. So that we need also to ensure that the different pipe wall thickness and grade marking on the alignment sheet, because along the way there is like we mentioned earlier, for example, for onshore, our pipeline construction will be based on the class category. For example, class 4, where there is a high density people, then we need to install the higher thickness material for our pipeline. So we need to properly align and allocate our line pipe during the stringing according to the wall thickness or different grade of our pipeline. So the third one is public roads and lands are not being damaged during the pipe hauling, as well as we shall not place our pipe on the ground or tread over it. So temporary stop pipe are safe and properly support. Okay, so and then proper end hooks are being used to load and pipe to prevent damage to bevel. Previously that I mentioned that it will very important for the next steps during the welding. And then we need to ensure that we required gaps are met for access right of way, that as from the previous figure that we mentioned that we need as access for the welding, access for the other construction activities, and then as well as a tallies are accurate and distributed accordingly as per our procedure. Okay, next. Okay, after we align or we put all our part line along our trenches, so the next process is our pipe bending. Okay, so pipe bending, there is three categories. So we call it as a cold bend, a hot induction bend, or elastic bending. So why we do the pipe bending? So pipe bending because most of our part line road is not straight due to the nature of terrain, due to if, for example, if we lay our part line at the mountainous area, so we might have some due to elevation, so we might have some we need to align our part line accordingly. All right, so hence we must perform the pipe bending so that we can fit in properly in our 3D profile of the trench that we excavate earlier. Okay, so usually that the pipe joint we will weld to one another before we perform the pipe bend. Okay, most of based on the experience or based on this project that we have conducted, so most of the pipe bends usually we do it at site using the cold bending machine. But however, the cold bending is not suitable for the sharp bend, so it's usually at the 40 D radius or below. All right, and then so if let's say we have based on the part line construction survey that we conducted earlier, that our part line route will have sharp bend, for example, is more less than 40 D radius. So we will require to perform the pipe bending using the hot bend. So hot bending activity usually we prefabricate at the factory, for example, and then will be delivered to site as per fabrication procedure. So the last one is the elastic bend. So any sharp or the small bend or any pipeline bending, we need to follow the requirement as per ASME B31.8 or ASME B31.4. Okay, so next, Swee. Okay, so after we have performed the pipe bending, we already align or our part line at the trenches. We already weld our pipe together. We already perform the pipe bending with the at the location where need to fit as per part line alignment. So the next one is we do the field joint coating. All right, so next. Okay, so field joint coating or the bare part of the part line surrounding the weld area. So usually our line pipe is around 12 meter long for each line pipe. So we need to join them together to make it a long part line. So the area where we join the line pipe usually is bare metal. So the other part of the part line is already coated with is multiple type of coating depending on our application. So those area that we performed the welding earlier to connect the line pipe, so we apply the field joint coating. Okay, so the field joint coating basically is to we apply to reduce the corrosion post construction or during the operation life of our part line. All right, so the we apply our field joint coating. Usually we apply about multiple layer or certain thickness based on our product to ensure that the whole length of our part line is fully protected. Okay. So there is multiple type of the fill joint coating. For example, we have the FBE type, we have a dual layer of FBE type, we have PUF, we have SPU. So all those type of fill coating, fill joint coating actually is depends on our application and our intention of this our part line lah basically. Alright, so next is alright, so for the lowering part line tie-in and the backfilling, I will proceed. I will pass to my colleague, Miss Aisha, to further explain on those mainline construction. Alright, so pass over to you, Aisha. Thank you.
Thank you, Salwanie. Assalamualaikum and good morning, everyone. So just to recap from Swee and Salwanie's point, after we have conducted the survey and also we have prepared the soil or site and we have performed the pre-installation part, which is the stringing and the bending. And then when we have joined, then we can proceed with our next step, which is the lowering in. So just now I just noticed a question, how deep is the trench for that requires shoring? The answer to that is that it depends on the soil type and also the water table. So if the water table high, you might see some very soft soil, so you might need shoring for safety issues. But we do have some rule of thumb. We have about 1.5 meter. If it's more than that, then we will require shoring for our trenching. So next please, Swee. So this is a picture of lowering in of our joint pipeline. So once we have welded and when we have completed our fill joint coating, as you can see, it is the green parts. So the next step is to carefully lower down the pipeline into the trench. So as you can see in this picture, we have side booms. And also we have cradles or belts along to lower down the pipeline gently. Next please, Welding. So as I mentioned earlier, the lowering in activities is meaning that we are lowering down the connected pipelines using side booms. And we have several side booms working in order for it to be a smooth process. And then after we have lowered it down, we need to ensure that our coating is still intact. So we need to re-inspect again our coating using a holiday detector. And if there is repairs required, then we will apply the repairs as necessary. So we have two types of, we have cradles and also we have belts used for lowering down the pipeline depending on the length of the section and also I think the diameter of the pipe itself. So any weights for buoyancy control will be installed by the lowering crew. So sometimes when we have a high water table in that area, we would require some buoyancy control measures, such as we install concrete mattress or culverts or something like that. So any weights will be installed during this time after we have inspected and after we have checked we have inspected the coating condition as well as when we have lowered down the pipeline itself. Next, please, Swee. So one of the important parameters to check during the lowering in is that sometimes we have in situ soil which is filled with rocks. So when rock is encountered, we require some sort of padding as Salwanie has mentioned earlier. So usually we just use sand or fine grain earth to be placed on the trench or inside the trench prior to the lowering in parts. So this is also mentioned here that it could be also supported on sandbags or suitable alternatives, but sandbags are usually cheaper. So it does not touch the native soil bottom prior to its padding, meaning because sometimes the coating, external coating for protection, external corrosion protection is very, what we say, fragile. It could be stretched or it could be damaged during our activities, construction activities. So we require careful consideration of the materials or the in situ site. Okay, padding also is being used for lateral support and also longitudinal support. Next, please, Swee. So as I have mentioned earlier, we have several inspections during the lowering in process. We have, we need to ensure that the pipeline is being handled, that it's not damaged on the pipeline itself, as well as the external coating. So the pipeline coating is inspected using holiday detector. And we also need to check that the side booms are spaced adequately in order to prevent overstressing of the pipeline itself. We also need to ensure that the minimum cover requirements are met, meaning that if the pipeline requires about 1 meter depth, so we have to ensure that our buried level is meeting that requirement. Next, please, Ling. So this is what we have, or the equipments we use for the lowering. We have pipe layers or side booms. So usually the capacity is about 15 to 100 tons. It requires counterweight, as you can see in this picture. And also it requires side-by-side stability and also slope capability, meaning that it could climb some terrain, or it could climb mountainous area as well. Next, please. Right, after we have lowered in, some consideration that we might encounter in our pipeline construction activities is the pipeline tie-in. So in this picture, you can see that the welders are in the middle of welding the joints. So, okay, next please, Welding. Meaning that the term tie-in means that we are connecting to the pipeline into a facility or to another pipeline system, or it could be we have two construction spread and we would like to connect the different sections of a single pipeline itself. So we have some preparatory work. This is quite a bit detailed. We have the preparatory work where we have to prepare the hole, the bell hole itself, and we need to install the skids to ensure that our trench are stable and also for stability. And we lowered down our pipe ends into the trench and supports on the skid itself. And then we prepared our equipments and pipeline itself. So another consideration that we need to ensure during the tie-in is that we have a stable location, as well as there is no water around in order for us to proceed with the welding activities. So stabilization and dewatering is part of the activities that we usually conducted for welding inside the trench. So then we have the pipeline marking and cutting. So we need to align our pipeline. One of the issues or one of the main concerns during the pipeline construction is that we need to ensure that our pipeline or joints are aligned, because we have quite stringent requirement on that. And then we use clamping and also gap setting as part of our alignment activities. So then we proceed with the welding activities and etc. Next, please, Julie. So, okay, this is an example of where we have two sections of pipelines that are already in the trench. So we are connecting two ends of the pre-completed pipeline sections. Sometimes when the construction is quite long, meaning a few hundreds kilometers, so we have separate crew or construction crew. So when they meet, then we need to do the pipeline tie-in itself. So, okay, all the operations are therefore carried out externally, and accuracy of cutting and preparation and alignment of the pipe ends by the welding is critical, as I mentioned earlier. Next, please. So the pipeline tie-in inspectors will monitor to ensure that the welding is done by qualified welders as per requirement. The pipe is being handled in order to prevent damage to the pipe and the coating. This is common theme throughout our construction activities. Pipe is aligned and welded without excessive force, meaning that sometimes when we put the pipeline inside the trench, we cannot align it together, meaning that sometimes due to the obstacle at site or maybe due to the terrain itself, we need to ensure that the pipeline is aligned. So that's where the challenges are usually when we are constructing the pipeline. Complete welds are how do we ensure that the welding are okay is usually we are using radiography on the completed welds, and we need to ensure there is no defects in the welding and need to be approved prior to backfilling. And all the weld areas are coated. This is where the field joint coating activities comes in, and we need to ensure again that the exposed pipeline is coating is okay because external coating is the main protection for external corrosion, because usually for oil and gas pipeline we are using carbon steel, and it is quite susceptible for corrosion. So we need to ensure that the external coating is not damaged even before we are using it. And then the backfilling, including padding if necessary, is done according to the requirements of the backfill session. Next, please, Ling. So we have come to the end of trench construction pipeline. We need to backfill again the trench, as you can see in this picture. So it involves replacing our spoils, tanah yang kita korek before, into the trench. So it will be compacted using heavy equipment. And normally we have a ditch line about 0.5 to 1 meter higher than normal grade to cater for settlement. The crown itself is about 1.5 to 1 meter. And openings must be left to allow natural drainage across the pipeline. So we need to ensure that we have adequate drainage, natural drainage, in order to ensure that there is no damage or there is no water table untuk geohazard punya issues lah nanti. Next, please. And our specification for backfilling is that the most common requirement by our local authorities is that we need to restore back the excavated area to the pre-existing condition. So as that is the minimum requirement, so we need to fulfill the requirements as indicated in the plans or as per specification, because different authorities have different requirement on this backfilling, but usually we understand that we need to restore it to the pre-existing condition. The backfilling shall be accomplished using suitable materials, meaning that we need to ensure that the materials we are using is not harmful or damaging to our pipeline and the coating. It is defined as the mineral soil reasonably free of materials that may damage the pipe installation, prevent through thorough compaction and increase risk of settlement. So we need to carefully place the backfilling materials and ensure that it is a relatively uniform spread all over the pipeline itself. In order to provide simultaneous support on both sides of the pipeline itself. So all surplus or waste material remaining after completion shall be disposed of within, as per usual construction methodology. Next, please. So this is a padding equipment, something that we use for to remove dirt or debris. Okay, so this is as you can see in the picture, It sieves the dirt to remove debris that previously would have been dumped back into the buried pipeline. So we use this padding equipment to sieve the dirt and backfill under, around and over a pipeline. So bolehlah keseluruhan guna yang ni in order to protect the pipeline coating from being nicked or chipped. So as I mentioned, this is a common theme throughout the pipeline installation. Okay, next please. Swee is we have a pipeline installation video for you guys. So please enjoy.
Pipeline construction and maintenance is a highly regulated, strictly monitored practice with continuous involvement from federal, state, and local entities, as well as Tennessee Gas engineers and safety experts. The construction process begins with land survey crews marking the construction corridor, center line of the pipeline, utilities, road crossings, and other environmental areas of consideration. The construction corridor will then be cleared and graded to remove brush, trees, roots, and other obstructions such as large rocks and stumps. The corridor will be graded to provide a level surface and safe working area for the pipeline crews to build and install the pipe. The process of grading the corridor may require blasting rock ledge to accomplish a safe working area. The topsoil will be removed and segregated along the working corridor for use during restoration. The center line of the pipeline is then staked in preparation of trenching along the pipeline corridor. In areas characterized by normal soils, the trench for the pipeline is excavated by crawler-mounted rotary wheel type trenching machines, or track-mounted excavators. The trench width and depth will be in accordance with U.S. DOT regulations. The excavated ditch bottom in areas of rocky soil conditions will be padded with clean soil to protect the pipe coating during installation. Pipe will be delivered to the pipeline storage areas and will be placed along the right-of-way in a continuous line in preparation of welding operations. Bending of the pipe will be required to allow the pipeline to follow the natural grade changes and direction changes of the right-of-way. Selected joints will be field bent by track-mounted hydraulic bending machines. For larger horizontal changes of direction, manufactured induction bends may be used. Following stringing and bending, the joints of pipe will be placed on temporary supports adjacent to the trench, carefully aligned and welded together by welders qualified according to applicable American National Standards Institute, American Society of Mechanical Engineers, and American Petroleum Institute standards. A Tennessee-approved welding inspector will conduct the welder qualification testing and document all test results. The pipeline joint lengths and identification numbers will be recorded. Each deflection angle in the pipe will be documented as part of the pipeline permanent records. Our projects also leverage the latest in pipeline monitoring and safety technology. For example, we ensure that the assembled pipe meets or exceeds the design strength requirements using X-ray or another approved test method. Electronic equipment is also used to inspect the coating quality and any damage is repaired. Once the pipeline has been welded together, coated, and inspected, the pipe is lowered into the trench. Once the pipeline has been lowered into the ditch, the survey crews will document the location of the pipeline using GPS instruments. This will become a permanent record for the life of the pipeline. The pipe is then padded and backfilled using special material to protect the coating, as well as the material originally excavated from the trench. A soil crown may be placed above the trench to accommodate any future soil settlement. Hydrostatic testing involves the pipeline being filled with water and maintained at a test pressure and duration in compliance with applicable federal regulations. Disturbed areas are smoothed out and the area is cleared of remaining construction items. Erosion control measures are put in place, including site-specific contouring, permanent slope breakers, mulching, and reseeding or sodding with soil-holding vegetation. Construction sites undergo thorough restoration and every effort is made to leave the area in its original condition, including seeding and replanting based on landowner, community, and agency requirements.
I hope you guys have a better understanding with the video. That is I would say, the common type of pipeline installation or construction for onshore section. So next, I will call upon my colleague, Cik Shaikh, to complete the special construction technique for pipeline installation. Please, Cik Shaikh, the floor is yours.
Assalamualaikum. Thank you, Miss Aisyah. The next, I will continue with this sharing session on the construction technique for this pipeline. So we have two types of construction. Next, you can move to the next slide, Swee. We have two types of the construction techniques, as mentioned by by Miss Ling, Puan Salwanie, and also Miss Aisyah. We have open trench and we have trenchless. Okay, when we use this, when and why we use open trench and trenchless, basically the decision of this open trench is coming from the authority. For example, in Malaysia, for road crossing, we have to approach Lembaga Lebuh Raya Malaysia, and we have also railway crossing. We have to approach Kereta Api Tanah Melayu. And also during this, at the start of this project, for any pipeline project in Malaysia, is governed by environmental impact assessment. In some cases that we open cut is not allowed, so we cannot do any trenching along the even at the specific areas. Example, at mangrove area, if you is our latest pipeline project going to Pengerang, crossing the mangrove area, and also we have river crossing, which are quite long, more than 200 meter, or sometimes during the PGU construction back in 1990s, early 90s or late 90s, we have Sungai Pahang crossing, about 1.5 kilometer. So in terms of construction techniques, it's very difficult if we want to do this open cut. So we have to look into the trenchless method. And again, as mentioned by Miss Ling earlier, there are issues on this temporary land that we have to rent the land. During at the crossing also, we need to at the certain area we need to lease the land from the adjacent landowner, just for this during construction. And over here in Malaysia, our environmental issues is become a concern at the mangrove area, where you're not allowed for this open cut. But in other area that Petronas exists, for example, we have a Petronas Energy Canada, where the environmental is very important. We are dealing with environmental issues on the One Nation, which is the natives of this Canadian. Some areas they do not allow open cut, so we have to go for trenchless. So we have basically okay, next reading, next slide, Ling. Okay, for open cut river crossing, basically when we install the pipeline, we need to approach Jabatan Saliran Pengairan. During this during the session, we present our cases, we present the method of our open cut method. Sorry, I got interruption. Okay, we have this open this is the typical crossing where we lay the pipe using the open cut method. When we approach Jabatan Pengairan, they will provide us the dotted line in the diagram below basically is the future part line cross section. So in our design, the depth of our part line section must consider the future part line section normally at 1.2 meter from this future from the dotted line. So we have to go lower 1.2 meter from the future cross section. So once we completed this drawing, we approach and presented back to Jabatan Saliran to get their approval, and then construction can start. Next feeling. Okay, this is just to show you the typical open trench method for the small stream. We have on the left is basically if the authority has no issue on this construction method, we can or the river is shallow and there's no issues on the environmental where the soil will be disturbed, our construction equipment can just cross over. And on the right method is basically how we lower down our part line in the at the cross section using this inverted coat hanger. It's like a coat hanger. Pick the part line and you just lay into the river. Next, Ling. Okay, for the open trench, this is the typical layout where we lay our equipment. On the center is our proposed part line construction, and our construction right of way is basically the one in the yellow. And during this construction, as I mentioned earlier, we may need to lease the adjacent land. So this temporary workspace is only required during construction. So we lease the landowner in the to the adjacent to our proposed part line crossing, where we put our spoil, our trench, our soil excavated from this trench. We store it there because this need to be used later during backfilling. And along this part line also, for this excavation area also required, if we use a horizontal directional drilling, we need to keep the bentonite in the trench, in the specific trench, so that there is because bentonite, we don't want the bentonite to spill over into the river. So, and at the same time, we want to recycle the bentonite to during the drilling bit to go through the process of this HDD method. So the excavation that required during this open cut is basically to keep the bentonite, and also to keep all this to prepare the groundwork for this construction process to take place. Shilling, next. Okay. This is another method of this construction method at this seasonal river. Normally, this in Malaysia we don't have any seasonal river lah. But if you go to like my colleague here, Asha Ahmad, he works for he attached with this Garaf project in Iraq. Over there, they have a seasonal river where during dry season, it's dry, you see nothing. And but during the rainy season, or not really rainy season, wet season, I would say, wet season or winter, where there is a rain, where at the time they receive rain, this dry area will be flooded. So if your construction time during this dry season, you can do open cut. You can do a normal trenching as mentioned by my colleague earlier. But if we did not plan your construction properly, or you cannot avoid the construction during this wet season, We need the other alternate method is we have this HDD, horizontal directional drilling, or we can use pipe bridge as an alternative method to open cut. Pipe bridge is basically we just put the pipe on the support like a bridge crossing the river lah. Over here in Malaysia, this will be answered in the Q&A just now. In Malaysia, we do not have any open bridge method yet. Just to share with the audience, during the feasible study to lay the pipe to cross this Johor River from as part of the Pengerang gas pipeline, they did put one of the crossing method on the bridge, but it was not installed because during part of the project also we need to do cost benefit analysis, and it may be due to cost. We did not install our pipeline on the pipe bridge, but instead of that, we use a normal method, HDD. So just to put you on just to share with you the comparison of the selection on the seasonal on this pipeline crossing for the seasonal river, and also at the river crossing. Okay, this is a same slide basically for the seasonal open trench. Seasonal open trench is we still need to put our construction method, construction spoil on the left hand side, where we need to, because later on we need to use this material for the backfilling, for the padding. There is no difference in the open cut, except that this for open cut we don't have any extra excavation for the bentonite bentonite to lubricate the drilling bit during the cutting the layers, soil layers, to cross from one end to another end. Next, Ling. Okay, this is the punching method, bore punch method. Basically, bore punch method is you lay the method is you punch using the hydraulics. Using the hydraulics, you see there is a boring machine here. This is bore or punch. Okay, this is auger method. You see the vertical auger there inside the casing. So the drilling bit will rotate, and it's like auger machine, but it is in the horizontal position. So as it rotates, we remove the dirt and will be transfer back to this open area. And once the auger machine or boring machine approach at the other side, then we will install the pipeline. We lay the pipeline. We insert the pipeline using on the wheel, on the railing, on the rail, and then is one of the method. The other method, punch method, is mentioned here. Is not in this drawing, but basically using the casing, and then we push the pipe using hydraulics, and the method is like ramming using this hydraulic. Normally, the selection of this method is depending on the soil type at this area. Again, I forgot to mention before this. We decide the decision on this crossing method. We need to do the soil investigation as well. If we discovered boulders, we may need to relocate the pipe. But if there is no other, if we cannot relocate this proposed crossing line, we have to use other method. Okay, Swee. The other method that I mentioned is horizontal directional drilling. So basically, there's a horizontal directional drilling is using this special machine equipped with GPS and equipped with bentonite pump, so that during the first drill bit pass through, we can position our part line according to the specific GPS location and also the depth, the required depth, and the bentonite is to assist to lubricate the drilling bit. So the first drill bit, we call it a pilot hole. So normally for pilot hole, we send a small diameter pipe, small drilling bit, and once it reaches to the end, we call it reaming, where we change the drill bit to a bigger size, and then this process will continue a few times depending on the size of your part line. If your part line is, you want to install 36-inch part line, the drill bit, the size of the hole normally is 2 or 4 inch bigger than your part line size. In this drawing, as you know, we did not show the location of the bentonite trench, but basically bentonite, the trench of this, the trench to store our bentonite is basically at the side of our drilling bit. So if on the drawings at the top side there, on the top one is the bentonite is somewhere on the left of this HDD machine. So the bentonite will keep on pumping to assist this the drilling activities. Swelling next. So I think this is we have a video to explain on this horizontal directional drilling. So enjoy.
Horizontal directional drilling, commonly referred to as HDD, is a surface-to-surface installation technique that is comprised of 3 primary stages, including pilot bore, reaming, and product pipe installation. This method of construction is typically used to install pipelines in areas not amenable for open-cut construction, including major water bodies, wide or busy highways, railroads, environmentally sensitive areas, and urban environments. During construction, no disruption occurs to any feature being crossed by the HDD installation. With proper design and good HDD construction practices, the HDD method allows for the installation of pipelines with no impacts to the crossing features. Limited workspace is established on both sides of the crossing to house the necessary drilling equipment and to facilitate product pipe string fabrication. These sites are cleared and leveled to facilitate drilling operations. Silt fencing and other erosion control measures are placed around the site. If necessary, sound curtains are erected at the drilling sites for noise mitigation. The drill rig and power unit is placed into position on the drill alignment. A drill pipe skid is positioned next to the drill rig. A small entry pit, approximately 5 to 6 feet deep, is excavated at the front of the drill rig to collect drilling fluid returns. A separation plant, holding tanks, and drilling fluid pumps are set up and plumbed with the drill rig. A control cabin is placed immediately next to the drill rig. This cabin houses the controls used to control the drill rig and track the drill bit location. Drilling of the pilot bore commences by pushing and rotating drill pipe connected to the drill bit along a predetermined path from the drill rig entry location towards the exit side located on the far side of the crossing. A mixture of water and bentonite clay, referred to as drilling fluids, is continuously pumped through the drill pipe to the cutting tools where it mixes with the soil or bedrock cuttings. This mixture flows back to the drill rig location, carrying the entrained cuttings, where it is transferred to a separation plant to remove the cuttings and recycle the fluid component for reuse downhole. Aside from assisting in removal of cuttings, The drilling fluids also serve to stabilize the bore, cool the cutting tools, and lubricate the pipe string. As the pilot bore is advanced, a tracking system is used to locate the position and orientation of the drill bit. Steering adjustments are completed by the drill rig operator to maintain the design alignment. When the drill bit exits the ground surface on the far side of the crossing, the pilot bore stage of the installation process is complete. The pilot bore is typically enlarged by pulling reaming tools of successively larger diameter from the exit location back towards the drill rig location. Depending upon the diameter of the product pipe, multiple passes with reamers of increasing diameter may be required to incrementally enlarge the pilot bore to its final diameter. Upon completion of the full reaming passes, the condition of the HDD bore is assessed by completing what is known as a swab pass. The pass consists of pushing or pulling a slightly smaller diameter reamer through the fully reamed bore from start to finish. The diameter of the swab pass is typically smaller than the full reamed diameter, but greater than the diameter of the product pipe to be installed. Like the pilot bore drilling process, drilling fluids are continuously pumped through the drill pipe to the cutting tools, where it mixes and entrains the soil or bedrock cuttings into the fluid. This fluid aids in removal of the cuttings, continues to stabilize the bore, cool the cutting tools, and lubricates the pipe string. Sections of product pipe are transported and positioned at the HDD exit location. The pipe sections are then welded together to form a completed pipe string. Coatings are applied to welds and tests are completed to ensure proper coating application. The product pipe string is then pressure tested with water, drained, and placed on pipe rollers. Pipe rollers and cranes, or side booms, are used to assist the pullback process. The rollers and slings used in conjunction with the lifting equipment not only provide support for the fully fabricated pipe string, but also help reduce the amount of friction acting on the section of pipe above ground, and reducing the overall amount of force required to pull the product pipe into the bore. The rollers and equipment are also used to position the product pipe to match the angle of the bore where the pipe enters the ground surface. Upon completion of the reaming process, and once the product pipe string is completely fabricated and welds X-rayed and coated, the final stage of the installation process, pullback, can begin. The pullback process consists of pulling the fabricated product pipe from the pipe entry location towards the drill rig. The HDD installation is complete when the product pipe reaches the drill rig location. Final checks and surveys are completed on the installed product pipe. With the completion of the pullback operations, the drilling equipment is demobilized and the work sites are restored to pre-existing conditions.
Okay, that is the actually how this HDD was performed. And if you can see that most of our sample we took from Kinder Morgan pipeline, which is pipeline running from Canada to Texas, if I'm not mistaken. And this pipeline is a bit controversial because it was designed during Trump and completed towards the end of Trump era. I think this is the last slide, Ling, on the pipe area bridge, just to show, just previous slide, Ling. Okay, basically this is the typical method of pipe bridge lah. It's just not from civil point of view. The construction of the bridge is just you install the bridge and you install the bridge. You install the pipeline on top of the bridge lah. And then the size of the from one to end depending on the weight, total weight of the pipeline, which is a dead weight, and also you need to consider the life load due to wind or due to other factors lah, environmental factors. Next, Ling. Then at the hilly construction, we have, as mentioned by my colleague here, the temporary trench plug, which normally we install to prevent this compacted soil, subsoil, because during the trenching, you already disturb this area. So even though you have compacted according to the our procedures, during rainy season, they may be exposed to soil liquefaction or soil erosion, just to prevent this at the especially at this hilly side, where this is the weakest point, where the soil become liquid and then it can flow, and this it can disturb it can affect our safety to our pipeline. So we install the soft plug using this apa ni, I think this one is a styrofoam or bentonite or any hard material lah. Okay, I think, Doctor, that is our last presentation and our sharing session. So from all of us, thank you very much. I hand over to you for this Q&A session. I saw a few interesting questions, so we take up in this session, Dr. Nick. So can we have Wani, Puan Sawani, Swee, Ling, and Aisha Ahmad on standby to take up the question? You are on mute, Doctor.
Thank you very much, Ms. Sheikh Abdullah, and also our guest speaker, Ling, Aisha Ahmad, and Ms. Salwanie Zakaria for the very great sharing session. So basically, we have a lot of the question is the chat box. So we can proceed for Q&A session. I started with the first question from Dr. Andre Kusberantoro. Is it there any specific justification when the pipeline must be buried and when it can be placed on the surface?
Nak take up?
So for this question, if it's buried or placed on the surface is depending on the local authority requirements themselves. First and foremost, we need to check that. If usually in Malaysia for oil and gas pipeline, we bury because we can better manage that way, because if it's on the surface, we will have so many issues from third party lah. Ada orang terlanggar ke, ada orang, so it's better in terms of managing the pipeline. It is better to bury the pipeline in Malaysia. However, there are cases that we have onshore on the surface, or what we call on the pipe rack. Usually it is designed that way, and usually it is in a controlled environment, such as between plants, and where you have control on the access or in the area lah. So basically we would see the local requirement first, and then on how to manage boleh control ke tak access kepada pipeline itself. That's my answer lah.
Okay, thank you, Ms. Aisha, for that answer.
Doctor, may I add something on this decision whether we bury it or to put on shore, above ground? Okay, over here Malaysia, during for this pipeline construction and also pipeline installation, we are governed under Petroleum Safety Act. So with Petroleum Safety Act 1984, we are following American Code of Standard, which is requirement is to be buried at 0.9 meter above the ground, below the ground. Okay, that's why in Malaysia our most of the pipeline is buried because of the code requirement. But however, as mentioned by and also it's from the integrity point of view, it's easy to manage. We can avoid the third party impact, excavator langgar, ataupun potential threat lah. Yeah. So if we bury it, we also protect our pipeline from this threat coming from third party, which is we cannot control. And if you look at the Trans-Alaska pipeline, where the pipeline is not buried, is because the pipeline is the area over there is permafrost is permanent. During winter, the land is frozen, but during a summer, the area there will become soggy and become very muddy lah. So in Trans-Alaska Pipeline, if you Google, you can see that everything is above ground. So the decision to install the pipeline above ground is because of the environmental impact, the environmental issues. So I think just to add on to Miss Aisha question lah.
Thank you, Ms. Shaikh Abdullah. So we proceed for the second questions. That one is relate to regulation. Just you mentioned before the Petroleum Regulation 1994. Is any safety issues or regulation needs to comply when do this pipe installation in Malaysia or overseas project?
Let me continue. As mentioned by Shaikh, we are governed by the Petroleum Safety Act. So that's for Malaysia. And just now the question is about the safety, right?
Yes. Safety issue. Any safety issue facing in the installation pipe in Malaysia?
For Malaysia, like we say, apart from the Safety Act, we need to comply to the DOSH, the Safety and Health Authority. So based on the requirement, we need to make sure all the tests, all the requirement is conducted before the installation. All the operator, the contractor need to apply for the permit to install. We call it PTI, and then later after installation, apply for the permit to operate. So this permit, there's a list of document or requirement that the operator or the contractor need to comply, so that we are governed by all this. So in order for the safe construction and operation of the pipeline.
Okay, thank you, Swee Ling, for that explanation about the Department of DOSH, Department of Safety and Health, and also need to comply with that before we install the pipe in Malaysia. So can we proceed for the next questions?
Dr. Nick.
Yes.
On top of it, Aisha will add on few answer in terms of safety during design.
Okay, sure.
Okay, on top of what Swee Ling mentioned earlier, the PTI and PTO, on the safety part, during the design of the pipeline itself, we manage the safety in terms of the location class. Location class means that the population part of the right of way, if we are going through a very heavy dense area, such as in Chalam or Puchong, so we need to consider a higher and thicker wall thickness in that area. So that is how we manage to ensure the pipeline doesn't burst or to adequately manage that. And after that, we also ensure that the pipeline is okay after the construction by using hydro testing, meaning that we hydro test the pipeline, we pressurize the pipeline up until there's a numbers of requirement on what pressure it could be, but we usually apply in up until 1.25 of the design pressure. So that is how we manage the safety part in order to ensure that the pipeline doesn't leak and can withstand higher pressure. Okay, that's all.
Okay, thank you, Ms. Aisha, for that thing. So we proceed for the next questions. How long the process of construction pipe and any installation pipe on this project to complete? And also, is it any failure on this construction pipe? If yes, what the cause it happened?
Assalamualaikum. Let me take that question. Okay. How long the construction process is it, Doctor?
Yes, yes. How long?
Okay, the construction, the installation, when we talk about construction, we talk about installation of the pipeline. The duration of the installation depending on the total length of this pipeline, and also normally during the bidding stage, during the bidding stage, we will put in the proposal that the duration for this pipeline to be installed, for example, 12 months, the longest, or maybe some of the pipeline can be installed during within 8 months. So to answer you, the construction is depending on the when our customer at the end require the gas. So we plan our construction time accordingly, but to achieve the construction window that is given to us, given to the contractor, normally they will come with the different numbers of construction spread, as shown in at the early stage of the presentation. We have a crew with the trenching, we have crew for this stringing, we have crew for this pipe laying, and also welding. So the most critical point at this pipeline construction is welding. Welding is the critical point because it 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 will control when the completion of this. Because if there is a fail, they need to cut and do the redo the process again. To highlight to all these our attendees today, in our presentation we focusly most on the civil part where we do the trenching, backfilling, and we did not include the details of the welding in this presentation because because the title is on the excavation, right? So we can talk about welding in detail of the remaining of the construction, but the answer is the duration is depending on the window given to by this when our customer require the gas. And the failure in our project, we have many failures. Our especially failure at crossing, HDD. Sometime during before the installation, as I mentioned earlier, during the bidding, during the start of the project, we do the soil investigation. We do soil investigation at the center or certain location at the proposed pipeline route. However, when come to the actual construction, we encounter boulders or we encounter difficulties. So for Pahang, Sungai Pahang crossing last time, the delay of that HDD crossing can up to 8 months. And when the contractor try to retrieve the drilling bit, it has to they have to excavate around 20 meter, 10 to 15 meter depth to excavate the drilling bit because that drilling bit is expensive. So they have to take up the drilling bit. So the duration is if we encounter duration, it can be long, can be up to 8 months.
Okay, thank you, Mr. Syed, for that thing. So basically, it also depends for the project location area, is it?
It depends on the location area because depending on the area where we cross the pipeline. Example, around KLCC ni kita ada land pipe, kita ada gas coming from Gas Malaysia. So the construction window can be done during at night sahaja because DBKL requirement no construction during daytime. So all this HDD activity buat malam sahaja. And then around Johor we have line gas pipeline running from Segamat to Pengerang and also to Tanjung Lansat bawah Senai. So during that period, we don't have any the environment, the development is still tak ada development sangat. So construction can be done very quick. But when there is a population, so there are the issues that consideration that we need to take up during the construction.
Okay. Okay, alright. So can we proceed for the next question? In construction pipeline, what is the most challenging work you are facing based on your experience? And what is your suggestion to ensure that our fresh graduate is well prepared when he or she wanted to become a pipeline engineer in this field, especially in constructions?
Wanita ada? Okay. Swee, want to try? We
Okay.
go around because the question is
Different
depending
experience.
on your individual experience. Okay, what we do is we share our experience. Maybe Swee experience is different from my experience. Aisha Ahmad may be different our experience.
Okay.
Alright.
My most challenging experience is to be the CSR, the site representative for offshore pipeline installation. So it happened during the monsoon season, during October to December at this Pantai Timur area. So we need to be able to have a strong mentor because you need to be on board on the barge for more than 2 weeks or maybe 3 weeks. So sometimes you need a support. I think we have a great team, and then the installation because of the season, monsoon season, some construction might need to be delayed, or we need to then backup plan need to come up with a backup plan and replan to make sure we meet our schedule. So going through all this, we still managed to complete our construction. So for the fresh graduate, what we need to prepare is, apart from what you study, I mean the knowledge you gain, for pipeline engineering, I guess it's not one engineering subject. It involves a lot of discipline. So apart from civil, we also need to, my background is civil, so we need also, when during working time, we need to be ready to learn and unlearn, so that we take more knowledge about other discipline like electrical for the corrosion and then materials. So that's the challenge, and that's what we need to learn to improve ourselves. Yeah, that's all from me.
Okay, thank you very much. So that's thing we need to prepare well. Either this one is not focusing for the construction or the civil area only, but we also need to take a look for the electrical, mechanical, and also compare with for procurement, for example, to purchasing that all this, a lot of the interesting subject they need to prepare. So the next, what the in situ testing method for welding pipe before put in the soil? Based on, I think this one is based on your video just now. They have a welder before the bury the pipe.
Okay. Testing method for welding pipes. Okay. Before testing method, meaning before we buried the pipeline, right? After the welding.
Yes.
After we join the two pipeline. Okay. For this welding, we follow code SME code 11104. After the welding completed, the joint must be X-ray using gamma ray with foot film. Macam kita pergi X-ray hospital, and then the film need to be interpreted and to detect is there any welding defect. So the welding defect can be gas porosity, where during the weldment you did not control the temperature, you do not control the voltage of this weldment. The gas can be can enter the weldment area and can be during the when the welding completed, the gas is trapped. Or another welding defect is pipeline crack. If you did not treat at the left side of this weldment area, if you do not put the heat treatment properly, if there's temperature surrounding too cold and the sudden drop of temperature, it can crack. It cannot detect by our naked eye, but during the X-ray, you can see the hairline crack. So that is the sample of this pipeline defect. So the method is for the welding. For this, there are two types of this inspection. First, X-ray, but on the surface, when after the completion of the welding, they put the final capping. They call it. For the final capping, for the small diameter, we can use dye pen inspection, where you spray the liquid. Normally is purple color. If there is a crack, you can see the clearly if you clean the area. If there is a crack, the dye we call it dye penetrant because it's a dye type. You can see it stay on top of the surface. So that is the sample of the welding testing method before we backfill our pipeline.
Okay, thank you, Mr. Shaikh. We have another question. In our classroom, we learn about the material for pipes. What the process to make sure that the parameter of pipes such as thickness, diameter, or coating types to ensure that it is suitable for the soil, the type of soil, and also the length of pipe of the project construction? Or how to choose the parameter pipe suitable with the area of installation? I think this one is the question actually wanted to know that what is the parameter to choose in terms of thickness, in terms of length, diameter, size. Because in the construction, you mentioned just now, they have the different area, maybe the different selection. And also the defect thing is due to the corrosion, due to the coating of the pipeline itself lah.
Can you take up? One froze. Okay, let me answer that. For this sizing, okay, last week I have sharing on this pipeline design. So to answer on this, how we from the material, if you're coming from this materials, from material point of view, during the design stage, before we lay the pipe, we need to ensure what are the customer at the end, in terms of flow rate. Normally we measure our gas in standard million cubic per day. So based on the flow rate and also the pressure at the end, we run our hydraulics. We use a software, either pipe sim or Auger, and we monitor based on the simulation. They will determine the size only. Okay, that is the first step. The next step is the line pipe is designed according to stresses. So the thickness of this line pipe, depending on the hoop stress. Basically, hoop stress is coming from the loading from the vehicles, and the loading will be transmitted to the pipeline, and also axial stress coming from the loading at from during the installation and also during the operation of this pipeline. So we have two criteria: the hoop stress, and also the thickness of the pipeline is depending on, as mentioned by Miss Aisha earlier, he talks about factor of safety. So we have, according to code, factor safety of class 1. Class 1 normally kawasan kelapa sawit lah contoh, or which is from and then we go to mechanical pula. From mechanical point of view, we design our pipeline before it start to fail. We call it specified yield minimal stress, SM, specified minimal yield stress, SMYS. So we design the curve. The curve is, for example, class 1 is 0.8%, 0.7% for class 2, class 2, class 4, class 3 is 0.6%, and also class 4, meaning that the thickness, if you go lower of the safety factor, the thickness of the pipe is thicker. So that is how we design the pipeline. So in the formula, we include the various factor safety, population density, installation method, and also temperature during the operation. So that is how we design our pipeline. And the length of the pipe is normally a standard. It's 12.7 meter because it's the mil. Due to mil limitation, it comes with a 12 meter pipe lah, more plus minus. Okay.
Okay, thank you, Mr. Sheikh Abdullah, for the great explanation. So can we proceed for the next question? Okay, how to detect the leakage of the pipeline after installation and operation? And how often the maintenance to ensure that the pipeline operate well?
For the leakage of this pipeline, along the pipeline system, we have, as mentioned earlier, we have location class 1, location class 2, location class 3, and location class 4. Along the pipeline, we have a block valve station. So for location class 1, we have spacing between 32 kilometer. So at this valve station, we have a detection of low pressure setting. So if there is a leakage, I'm talking about big leakage, sudden leakage, the pressure drop very drastic, and this alarm will be sent to the control center. In this case, our PGU system in Segamat. So in our panel at Segamat, they see an alarm, and then they can shut down the line pipe remotely from the valve station, and they will send the people. That's how, in terms of pipeline leakage, from the operation center. But if you go from the website, there is a lot of technology that you can detect this pipeline leakage using the pipeline leak detection system by installing fiber optic cable along the pipeline. So if there is a leak, the noise will be picked up through this fiber optic cable and will be transmitted to the control center. So they can identify there is some movement at the ground due to vibration coming from this gas leakage. And how often this maintenance? The maintenance is from maintenance point of view, on the ROW, right of way, they have a surveillance. People coming will do the inspection on the ground to see is there any encroachment. Normally it's done once a year, or 6 months or once a year, depending on the location. Kalau kat Subang Jaya tu, maybe they do it every 6 months because it's 2 weeks. Sorry, my colleague said 2 weeks. Every 2 weeks, Subang Jaya, they run through along the roadway, the drive lah, to see any encroachment, because the area is a lot of activity, construction activity, even now pun. All right. That is one of the surveillance. But for this pipeline itself, we run the intelligent peak tool. We call it pipeline intelligent peak PIG, pipeline inspection tools, peak short form. So this is basically a magnet. We run from one point A to point B using this simple method using magnetic flux. And then as it travels along the pipeline, it will detect the changes of the wall thickness. And if there is a corrosion, there a signal will be recorded, and when the vendor receive at the other end, they will send this to their lab and do the analysis, and they will inform you this location, what are the metal loss, how many percentage, and what, and then will be presented to us lah, and then we can plan for if it's external and it's critical. We need to do some inspection like open, cut, and verify. And it's a confirm, we do the maintenance lah, like repair, wrapping, or if severe, we do cut and replace.
Okay. There is the small.
If
Swani
if I may add,
yes, please.
yes, apart from those activity that we've done, actually for onshore pipeline, actually did engage with the villagers or with the community lah. Basically, we educate the people that live surrounding our right of way on how to detect leak. So we do engagement yearly. So we educate the people. Let's say if they nampak macam our pipeline is buried. So if let's say they nampak dekat on top of our pipeline, kalau dia punya grass tu dah turn to yellowish, so it indicate there is some gas leakage. So mungkin gas tu dia tak leak in a big leak. So they just leak macam sikit-sikit kan. So it will affect the soil surrounding, and the grass usually turn to yellowish lah. Macam that one incident that we have in Bekok or Segamat earlier. That actually the villagers that call upon our operator saying that they nampak macam potential leakage to our pipeline. So that what we do. So usually we do the engagement with the community yearly with the authority to educate the people. So what type of leakage, sebab at some location macam yang kita buat dekat PGB, because we have 100 kilometers of pipeline that we can't afford. Apa tu, kita tak sempat nak patrolling, basically go along our pipeline every day. So we sometimes we collaborate with the villagers lah, so that they can just respond to us. Kalau if dia nampak any leakage, kita akan bagilah dia signage of the potential leakage to that pipeline. Right?
Alright. Thank you, Ms. Salwanie, for the great explanation. So we go to the next question. What is the research potential for further investigation or approach to enhance the service life of pipeline? Is it any kind of research potential in terms of corrosion or other things due to construction pipeline?
You asked the keyword, so you just touch the keyword. So Miss Asha will answer it.
So basically right now, the keyword is research, is it? We are very much into we are very much into big data right now. So we have several big data analytics, I would say research ongoing for, let's say, corrosion. We have a very good database for internal corrosion, and we are going to embark for, let's say, external corrosion, big data analytics, predictive analytics. So as well as geohazard, as well as third-party encroachment. So we have several digital analytics or digital
predictive
analytics going on. So that's one part on going forward. We are going for digitalizing our pipeline integrity management. Kalau yang the hardware, kalau the hardware part, so we do have include sensors. We develop sensors. We do include sensors to be embedded in our equipment, so that we can couple it with our prediction analytics as well.
Yeah. When we talk about machine data, big data, we also nowadays people talk about digital, right, Doctor? So we from our pipeline engineering department, we talk about machine learning as well. So later on, all this inspection will be picked up through our sensors, and we'll come up with a probability of failure, and we come up with a schedule inspection and maintenance. That is our part of the future lah.
Oh, Okay. So is it using the Internet of Things or drone maybe somehow to see the
Right.
along the pipeline?
Swiling, you may add on.
Yeah,
Again, you touch you.
you touched the key point. Yeah, okay. As what mentioned by Aisha, Petronas, or especially our pipeline department, is going through this initiative so that we perform more things by not robot,
Drone.
what you call it, human, less on human touch. I mean, so we have this using drone and helicopter to do this inspection along the pipeline. So as the way forward, we see that we have more and more technology coming in to assist all the inspection and maintenance to avoid all the, because we know like pipeline, especially onshore pipeline installation is at mountainous and maybe certain area that which is not accessible and might cause some safety issue to the operator. So we try to engage and work together with the industry to come out with the technology so that we can have a better maintenance of our pipeline. Yeah.
All right. This is we also have a question about the erosion problem. When we install, is it the same method? And how to avoid this problem occur in the underground of the pipeline?
I think you're talking about the geohazard issue, right? More on the soil.
Yes.
Soil issue. So this one is the same as what we do for civil work also. Is what a geotech team. For this, we always work together with our geotech team to come up with the methodology. If they need a soil nailing or they need ship piling or any installation method, civil installation method, then we'll get the advice from the civil team.
Oh, all right. And then how to register as a vendor, as a constructor or contractor in Petronas for upcoming project?
Ask the boss.
We have a question how to register as the vendor. Let's say they have a project and then
How to become a vendor?
how to become a vendor? Is it
All right.
specifications or?
In our Petronas website, petronas.com, under business, I think you can register first. You can register your technology, and once upon registration, it will be picked up by our custodian, and we will do the assessment. And also in our website petronas.com, there is there is innovation marketplace, marketplace or technology ventures, where you can register as a company to become a registered vendor with Petronas lah. So that one is our procurement will do the assessment. They will evaluate. There are certain standard form for you to fill up and also criteria lah. So that one is under group procurement. But when it comes to technology, specific for pipeline, Miss Ling, Miss Aisha, Puan Nosawani is one of the assessor to evaluate your technology.
Means that all the vendor outside out there can also register in the Petronas as a
Correct.
and try to approach as a vendor that say have that potential, fulfill all the requirement of the Petronas side, so they have a great opportunity to become a contractor. Is it?
Correct. Once it's registered, they will provide you the code, and if there is a potential open bid, they will call for. Normally, the process is called a pre-qualified bidder. They send all the questionnaire to this company registered and already pre-approved by our group procurement. The answer is betul, Dr. Nick.
Okay. So thank you, Dr. Syed. So we have a question. Again, we have a question about the related to the material. What is the best material for the piping, for the pipe?
Aisyah nak jawab?
Okay. Usually for material selection, we look into the cost, the life cycle cost. So we have several types of materials. Usually we use carbon steel. Our rule of thumb is using carbon steel, but there are certain situations where we need or we can go for GRE or corrosion resistant materials such as CRA, flexible pipelines, and etc. So there is a combination of the capex as well as the opex. Sometimes carbon steel opex is very high because we have to manage corrosion or anything. So to answer your question, basically it all depends on the life cycle cost itself. So we does not look into the capex, we also look into the future, and we balance it, or we justify the usage of material by using life cycle cost.
Okay, thank you.
Let me add few things there.
Okay.
What Miss Aisyah mentioned is depending on the hydrocarbon property. If it's a high CO2, we may use cladding or corrosion CRA, corrosion resistant material, or high H2S. We cannot use normal carbon steel. We use other exotic material lah. CRM, corrosion alloy, ataupun internal cladding, internally clad with different material other than carbon steel, or we can go from metallic to non-metallic pipe. So we can have a thermoplastic pipeline or HDPE pipeline, but it's depending on the pressure that you to be transmitted for from point A to point B. We did use the current technology. Now we can have a HDPE pipeline for up to 60 bar. So the technology is evolving as we move on.
Okay, thank you. So that is due to the property itself, like the liquid itself want to flow across the pipeline, is it?
Due to hydrocarbon property, is it high CO2 or high H2S? Because this is the contributing factor to our internal corrosion issues.
Okay.
One of the pipeline threat.
All right. Maybe if in future we can have the investigation on that for the material property itself.
Inshallah, we can have a session on this next year. We can plan on the corrosion material. We can engage. We can collaborate with our pipeline. As we have a department under MCI, we call it MCI, material corrosion and inspection. So they are specialized and come to corrosion.
Yes. Maybe the next time we can have the session about the corrosion, maybe for the pipeline.
Inshallah.
Okay, so we have a last question. Okay, what are the soil exploration methods can be used to identify the stratifications of soil in order to implement the horizontal directional drilling? Can we use CMITS or recessivity method?
Okay, for HDD, normally we use a typical borehole. We just normal method lah, borehole drilling method, and then we take the sample and send to the lab. For seismic method, normally we use seismic method during the exploration or subsea survey. Salwanie, you want to add? Salwanie is coming from offshore. Salwanie is offline. So we did not use any seismic lah for HDD. We just use a normal method using a borehole. And resistivity method ni we normally do this Macintosh and Auger, where we want to identify the soil resistivity for this our corrosion protection design, CP design. 3P 4 pin. So resistivity method ni is the answer is no. For HDD we only use normal soil boring method. That's the answer, Doctor.
Thank you very much, Mr. Syed Abdullah and DVDN for our Q&A session. Okay, thank you very much again for our 4 guest speaker, Mr. Syed Abdullah bin Syed Othman, Ms. Swee Ling, Ms. Nur Salwanie binti Zakaria, and also Ms. Aisyah Ahmad for answering those questions and then for the great presentation and sharing session today. So it was my pleasure to have you with us today. So thank you very much for attending, and also we hope that our students have learned a lot about the construction pipeline today and enjoy this sharing session. So now I'll pass for this slot to the MC. Thank you very much.
Thank you, Technologist Dr. Niknor Munira binti Mat Hassan. Next, we would like to invite ladies and gentlemen for the online photography session. You were all asked to open the camera.
Thank you, Doctor, for the opportunity from all of us.
Welcome, most welcome, Mr. Syed and others guest speakers. Hopefully, we can have the next sessions for the another slot next year.
Inshallah.
Thank you very much.